In the United States, educational equity is a major social issue. A study conducted by the Department of Education found that 45% of high poverty schools received less state and local funding than was typical for other schools, meaning that students in these areas receive less education and therefore less opportunities. Our project, NeuroScribe, addresses the problem of educational equity by providing a free service for anyone to improve their English or find that perfect word. We trained a model on a huge dataset of blog posts to be able to predict how likely a given word would appear. If the word within the text does not make sense within the context of the sentence, then the word is flagged and a suggestion is recommended.
For example, I feel really tired today and think I might gone to sleep. As you can see here, the model correctly identifies the error and also provides a correct suggestion. Here's another example. A yellow word makes sense in the context of the sentence and is perfectly fine. However, a program may have an alternative. An orange word has been marked as not common and might be replaced. A red word probably does not fit and should be replaced. You may wonder, with all the grammar checking tools out there, why should there be another one? The answer is simple. Our model, unlike a service such as Google Docs, checks words for whether they make sense in the context of the sentence, going one level beyond simply checking grammar. As an example, if our second example was pasted into Google Docs, you can see that our suggestion replace words with meanings. Docs will correct basic grammar, but it would never go as in-depth as NeuroScribe, since the program understands the context of the sentence.
The model works using natural language processing and a bidirectional LSTM. To train the model, we first aggregated all of the blog posts and cleaned them up, feeding the aggregated data into a custom tokenizer. Next, we tried various hyperparameters, batch normalization, and dropout. Unfortunately, the model just would not converge with bigger data. Then we realized that our LSTM was only processing in one direction, which meant that the model was severely constrained and could not make good predictions. The model would not be able to see the context after the word being processed, leading to a huge loss of the understanding of the text. Once we switched over to a bidirectional LSTM, the model trained much faster and achieved much better results. We then made the backend and front end to be able to display accuracy and suggestions quickly. As a final step, we hosted our model on a server and bound it to a domain to make it accessible to everyone, reaching our goal of educational equity. We hope that this project can help everyone gain one more educational opportunity, improving equality for all. Thanks for checking out our project and presentation. Feel free to try it out for yourself at neuroscribe.cloud.